Hello everyone, and welcome to Nailing Your Thesis, our course on how to perform research. In the last few sessions we have discussed the general process of science and what constitutes scientific work. In this final session on this general part, we will talk about the ethics of science and what it means and how it leads science and the scientific progress. After that, we will dive into the methods section, first on exploratory research and then on confirmatory research. But for now, it is the ethics of science or the practical ethics of the researcher. So things can go wrong. Mostly this session will be about unethical behavior, how to recognize and how to avoid it. And there are really two sources of unethical behavior in science. And one of them is simply lack of competence, and the other one is the deliberate fraud. You may think that lack of competence shouldn't count, but actually lack of competence, not being at the state of the art, not understanding best practices, will lead researchers straight to unethical behavior, even if the research is well-intentioned. So we will discuss these two sources of unethical behavior in detail now. Here's a little quiz to get us started. We are talking about well-intentioned research, but still potential unethical behavior. So what do you think? Can you provide examples of the following forms of unethical behavior in well-intentioned research? And as you can see, it's split in a general section and in one on dealing with human subjects, which is usually a major source. So I already gave you the broad categories. So how might research be unethical where the subject may not agree or where the human subject may not understand? And how may research be unethical if there's low beneficence and or no scientific value? Beneficence means weighing the benefits and the harms, and low beneficence means that there is little benefits when compared with the harms that research causes. And maybe you can think of another source. So TA, please stop and discuss in class this question. All right, I hope you had a good discussion. Here are some examples of unethical behavior that I came up with in the category of human subject may not agree. I thought back to the Milgram experiments. What if a human subject agreed to electroshocks as part of an experiment, but then decided to withdraw, but gets ignored because the experimenter thought, oh, maybe that withdrawal would hurt my experiment, and so ignores the subject, and that would be highly unethical. Or a research setup is such that the human subject doesn't understand what they are agreeing to, even though they might be providing consent. For example, accepting as part of the research to be put into a psychologically highly stressful situation and not really understanding the toll it could take on them, like not being able to sleep for days, for example, being exposed to watching horror movies as part of the research. An example of low beneficence I made up here is like, what if you dump a lot of trash into the environment because you have some research or want to do some research as to how an environment may be able to heal itself? Now that sounds like low beneficence to me. Why would you waste or ruin the environment for gains or knowledge you could be gained in less harmful ways? I didn't provide an example of no value because that's often debatable. We will be reminded later on how science is supposed to be beneficial to society, but what that is of course disagreeable to some, in particular if you believe in pure science and knowledge for knowledge's sakes. A hilarious example in the United States for a while ago was research into electric or electronic bees, small robots that behaved like bees, which were totally torn apart by politicians, but actually showed to be providing significant value on the computer science and autonomous robot research level. So let's look at this in more detail from the perspective of how to perform ethically sound research, because that's what you want to do ultimately. Here are the 4 categories that I took from the Singer and Winston paper from the course reader. Your research should be based on informed consent if there are human subjects involved. There should be recognizable scientific value, there should be a sufficient beneficence, and you must maintain, again, with human subjects, confidentiality of the data. In more detail, informed consent means 2 things. So first of all, informed consent with human subjects means informed, means there's honesty in disclosure. The researcher thinks hard about what it is, what the subjects who will hopefully consent to some research study they are to participate in, needs to think really hard what to tell the study subjects so that their decision to participate in the study is based on a really informed, proper consent. So the researcher needs to explain the purpose, all the procedures and the risks involved, can of course talk about the benefits, but the subject of the study needs to understand and fully comprehend what it might mean to them. That means informed consent. And then of course there's the actual consent, so the subject, the subject of the study, one or many, usually many, need to consent, and that consent needs to be free and voluntary and intentional. So there should be no coercion, no undue influence on the subject's decision to consent to sign off on some form. It should be understood that the subject at any point in time can change their mind, so they can withdraw consent, and the researcher must prepare for any subject pulling out of the study at any given point of time. So good ethical research has scientific value. Scientific value, of course, is hard to measure. The simple framework we've discussed already, which is the 2 dimensions of rigor and relevance. So the combination of these 2 should be significant, meaning non-trivial. That value, of course, might have to be weighed against any potential risks of performing this research. Beneficence is related or similar to that, but it's really about the benefits and the harms and weighing those such that the benefits outweigh the harms, again by a significant margin. All of this applies to any potential level of application of the research, whether it's animals, human subjects, organizations, or even society as a whole. Finally, good ethical research treats its data confidential. Certainly, human subjects should not be identifiable, and the data gathered should be, at least initially, limited to the defined purpose. And if you extend the purpose, if you change it, if you ask new research questions and believe you can answer them with the data, you may have to get consent again. So here's another quiz. What are challenges to informed consent? Is it so trivial or easy to get proper informed consent? TA, please discuss. So I hope you had a good discussion. Here are some examples of challenges to informed consent. At university, we of course love using students and experiments because they can't run away, which would be one problem. So of course students, if used in research experiments, need to provide informed consent. free of coercion. And naturally, there's a power relationship between, say, a professor and a student. So there would be undue coercion if, for example, the student had any expectation of better grades or avoiding worse grades. And so any such research may not use or must avoid it at all possible costs such coercion. Related or similar or well difficult relationship is parents allowing the use of their children at an age where they cannot decide for themselves to participate in any research study, in any experiment, or even a longitudinal study over many years, while the parent as the guardian can make the decision legally for their offspring. What does it mean for the child to become an adult and find themselves possibly in a study they may not have agreed to, not even talking about breach of confidentiality, which is not assumed here. Finally, use of data for new research. Well, that's actually what researchers love to do. They already have high quality data and now they would like to ask it new questions. And but what if these research questions violate some religious beliefs or so of those who originally consented to the data gathering? They may have to be asked again and they may disagree with their use of their data in such studies. So it's not easy. For the researcher, in particular the young researcher, where it may not be obvious, can I do this, shall I do this? There are two steps to take. The first one is very pragmatic. If you have a grumbling in your stomach, ask yourself, would you want this to be done to you if you were the subject if you were the subject of a study? That already might provide a good indication on whether it's ethical or not. However, things can be tricky very quickly. So most universities, certain or large research institutions have a so-called ethics review board, which will provide an informed opinion and might even veto your research, provide an informed opinion on your research and might even veto it. So you may or may not have, depends on your institution, to go to that ethics review board, lay out your proposed research projects, and they will tell you any potential problems they see and may even tell you that you actually cannot perform that research for ethical reasons. All right, let's move on to the second part, actual scientific fraud, fraudulent behavior of researchers. That has been and always is in the news when it comes up. But it really is a problem if science isn't conducted properly. Now, science, fortunately, has a way of healing itself or patrolling and controlling itself, if you will. And one aspect of that are guidelines or even requirements that you have to agree to before you get funding on how to conduct your science, your research properly. So here for Germans, for example, is the Deutsche Forschungsgemeinschaft and the rules or practices for how to perform good research. Similarly to the DFG, there's the MPG, MPG, the Max Planck Gesellschaft, which also has provided rules of good scientific conduct. And then there are a couple of other manuscripts that will give researchers guidance on things to do and things to avoid. So let's look at scientific fraud or fraudulent science. You may wonder, why would anyone do that anyway? So first of all, to recognize what is scientific fraud? Well, it's anything that goes against the purpose of science but declares itself science. The purpose of science, somewhat abbreviating here, is the pursuit of validated knowledge, to gain insight into the world in such a way that we feel it's validated, it's correct knowledge, again, for prediction, reliable outcome, etc. and also this is to benefit society. So scientific fraud is anything that claims it's science but does not match this definition. It's only taken serious if it's past quality controls of science and is considered science by others. So that's the intention of the creator of fraudulent scientific papers, for example, to actually fraud other scientists by making them believe their research is valid. So again, why would anyone do that? And it boils down to other motivations than the purity of science, potential conflicts of interest, because researchers are human beings and as such are more than pure thought stuff, more than science and theories and models and frameworks. They have other interests outside of science. So here are a couple of categories of motivation for scientific fraud. The first one is personal psychological disorder. By that I mean someone who has psychological problems which make them perform fraudulent work for something to gain, like personal satisfaction out of reputation, even though it's based on obviously fraudulent work. Other motivations are to advance your career, for financial gain, to meet performance goals put upon you, to get better than justified grades from your actual work, or to confuse and mislead the world. Anyway, TA, please stop and discuss these categories and ask for examples of fraudulent behavior that might fall into any of these categories. All right, so I hope you had a good discussion. So here are some examples that I thought of. Well, personal psychological disorder. I don't mean it here as a clinical term. I'm not a medical doctor or a psychiatrist. I simply mean someone faking research because even though the reputation they gain is ultimately fake, they psychologically benefit or feel good about that reputation gain. Related to that is that reputation, even if based on fake or fraudulent work, as long as it's reputation that helps the career of some individual researcher, it might be undertaken. And examples of that are, for example, the problematic and now proven wrong and fake studies on vaccination and autism, leading to all kinds of harm in the world. For financial gain, personal financial gain, well, there are always or too often studies of trials of medical drugs that are being rushed to market, where medical doctors might be induced using money to perform less than perfect trials to get the drug approved. To meet performance goals, that is a current problem in some countries in the world where stringent governmental or university or departmental requirements to meet performance goals lead scientists to fake research and get publications out just because, well, it's a performance goal set to them. Fortunately, you don't really have that at German universities, but there are countries, and you can read it in the press, where a lot of this pressure has led to fraudulent publications, which eventually get caught. And so right now you can see how high quality journals even are rolling back poor or fraudulent research that managed to slip through in an amazing numbers. It's horrible. And so this is a consequence of some dean being pushed to lead a world-class department, and the way they try to achieve that is to push hard on performance goals, on the researchers, on the professors to publish such and such many publications in a given year. Well, students might be motivated to cheat in order to get a better grade, cheat on a research project. Of course, we hope you don't, or our students, of course, don't. The final motivation to confuse and mislead the world, assuming bad faith like this, to my extent, that really doesn't happen. If at all, that's probably a fantasy. Pure malevolence, I don't think exists a lot, significant amounts in research. So the consequences, nevertheless, are dire. Poor or fake or fraudulent research published is considered to have passed quality peer review, is assumed to be true, and hence others start building on it, products start building on it, in particular medical products may start building on it, and if it's based on fraudulent work, it's just not true, it doesn't work, it will harm animals, people, organizations, and society. So scientific fraud is to be taken very serious, and science doesn't want it. Science has all kinds of ways of figuring out scientific work, fraudulent work, but it may take its time. And while something has not been recognized as fraudulent work, it may lead to all these harms, like the fraudulent work on the connection between vaccines and autism. And this aspect here is Retraction Watch, a website that actually tracks retractions, is providing a list, an overview of things that have been recognized as fraudulent as they're being pulled back, as the authors are suffering or facing the consequences of their fraud, etc. I really only recommend you go there if you like watching horror movies or anything. But it's an example of how science tries to heal itself, also of course by getting the word out, and if you will ultimately it's embarrassing people. So let's assume you got caught, or well, not you, but some scientists. The consequences in terms of harming the world probably happened, or hopefully not much did happen, but now the consequences are about the researchers suffering from their work having been recognized as fraudulent. The individual consequences are you or the researcher might lose their funding. They might lose their reputation. They might lose funding even before they lost reputation, because, or in conjunction with reputation, because as you agreed to take funding, you sign off on performing research only in the most ethical way. So it's legally agreed upon. Your funding can be retracted if you are shown to have behaved unethically. The loss of personal reputation may lead to end your career even, may even lead to you finding yourselves in the courts and some legal proceedings. And if you lose, you might even suffer financially from it. In addition, beyond the individual consequences, there are the disciplinary consequences. If, fortunately it's not, but if scientific fraud was rampant, people would be more hesitating to work with each other. There would be lots of friction and loss of speed in collaboration, and science would suffer. Also, and equally importantly, in the eye of the public, science that is too often shown to be fraudulent would lose the public's trust. That is highly problematic, as we need science to lead the way in unbiased, validated knowledge about the world in order to provide a counterpoint to hyperbole or plain lies by politicians, as we can see them all too often. As a budding scientist, some of you perhaps help make sure that the public does not lose trust in science and scientific progress. It has gotten us where we are, but we still need to keep going. So how could you possibly go wrong? Well, you don't follow good scientific practices, assuming not only if you are deliberate, well, you can do all kinds of things wrong, but even if you are well-intentioned, you could go wrong by not treating your data properly, by not following research methods properly as the state of the art would tell you how to do it, Of course, they mentioned deliberate falsification and deceit, or simply not even thinking about the consequences. There's just a gazillion of things of how you could go wrong. So I've only provided a couple of examples here. In general, what you should try to do is to do it right and to hold yourself to the highest possible standards, meaning understand what you're doing. The lack of competence, even in well-intentioned research, might lead you to unethical behavior. So you absolutely need to understand what, even if it's only temporary, what today is considered state-of-the-art best practices. And that's what you have to follow. So you need to track what the best practices and proper processes and procedures are. In general, you need to maintain a high scientific skepticism and attitude towards anything you see. Don't willfully follow wishful thinking because you hope your data will give you the results you want to. Be skeptical of your and other people's work. Be mindful of your colleagues, meaning recognize that while you're competing, you may have to still should treat them fairly, and acknowledge, for example, any contributions they might make to your work, because it's all embedded in the overall pursuit of validated knowledge, the noble quest of science. Treat data properly, safely and securely, collaborate fairly and properly, give credit where credit is due. As you publish, list everything that needs to be listed, needs to be said. Don't hide any detail that might question what you're putting forward. Equally, provide fair reviews of other people's work, open and complete as you can, without any hidden agenda of yours. And if something goes wrong, organizations need to provide an ombudsperson that you can turn to or that can help you, and certainly need to protect whistleblowers who put their career on the line by pointing out, for example, unethical behavior of research scientists. We've got a list of papers here, the DFG paper, the MPG paper, some others that you can find in the course reader. Please read up on those to learn more details on proper scientific behavior. So then, in this session, we looked at unethical behavior in science and the two main sources, lack of competence as well as deliberate scientific fraud. For the lack of competence, to counteract it, you simply have to build and maintain that competence at the state-of-the-art best practices. We discussed 4 principles of ethical behavior, with perhaps the most important one being informed consent of anyone who participates. And we also looked at deliberate scientific fraud, how it's motivated, how to do it, how you're led, or how researchers may be led to it, but also how to not do it, but rather perform best practice-based research and stay at the state-of-the-art. That's it for this session. Thank you very much for your attention, and after this we will switch to the methods sections where we will teach you about the different research methods available to us and the scientific world. Thank you again for your time and interest.